the standard normal distribution. Let's assume that heights of sixth form students are normally distributed with a mean of 160 centimeters and a standard deviation of 10 and variance of 100. And if we randomly select one student and we try and work out the probability that the height of that student is more than 170 centimeters. So there's 170 centimeters. It says more than, so I'm going to shade to the right here. So now I need to work out the area here. Okay, because this is just a probability density function. And you might be thinking at this point, we can use integration to work out the area. The probability density function for the normal distribution is this. And we're not going to integrate this. The integration has already been done for you, and probabilities have already been calculated for you and have been tabulated in a table that's given to you in the formula. The table is on page 19, and you can see probabilities here. You've got something called Z values along the outside, and you've got probabilities on the inside. This is a very special normal distribution. It's called the standard normal distribution that has a mean value of 0, and it has a variance of 1, and hence a standard deviation of 1. This is the only normal distribution where probabilities have already been worked out for you and tabulated like this. So going back to our problem here, this distribution doesn't have a mean of 0 and it doesn't have a variance of 1, so you can't directly use the probability tables here to solve this problem. We must first go through a process called standardizing, and then we can use the tables and the probabilities here for our calculations. The standard normal distribution is represented by the random variable z, and it has a mean of 0. So there's the mean right in the center, and z goes along here, and it has a variance of 1, and if we square root the variance, if we square root 1, we get the standard deviation, which is also 1. And from the mean, if we go 1 standard deviation on each side, so that's the mean, plus 1 standard deviation, minus 1 standard deviation, plus 2 standard deviations on each side, like this, and from the mean to 3 standard deviations on each side. So these are the z values for our standard normal distribution. Okay, let's say we're trying to work out the probability that z is less than 0.468. Okay, so 0.468 is about here. Okay, so I'm looking for this region here. So to look up the probability from the table, .4 is here. So that's this part here, 0.4. So that's the first decimal point here. The second decimal point, okay, so we have the first decimal point here, 0.4. The second decimal point is 6, and that's here. So that takes us to this value here, and that's a probability there, 0.6772. And then the third decimal point for Z, which is 8, here. And if we follow that down to our row, that gives you 29. And it's telling you to add that value to this. 29. So what you're doing is this. So we've got 6772 plus 29, 6801. So 0.6801. This is the probability. That's the answer to that question. So 0.6801. That's the probability here. If you wanted the probability on the other side, you know the total probability is 1. You would do 1 minus 0.6801 to get the probability on this side. Okay, that's a very basic example of how to work out probabilities using the normal tables. And as you can see from here, the accuracy for Z values is 1, 2, 3 decimal places, and for probabilities, you can see from here we've got 1, 2, 3, 4 decimal places for probabilities. So if you were trying to work out something like this, the probability that Z is less than 0.2589, well, you know that Z in the tables has an accuracy of 1, 2, 3 decimal places. So you need to round this to 3 decimal places first. 2, 5, 9.